we've pressed the red button, so that means this is recording. So anything you say is possibly to be recorded. Just want to let you know.
Drupal is awesome.
Drupal is awesome, yes! And full disclosure, John and I were front-end developers. Neither of us work on Drupal directly. I did set up a Drupal site the other day just to play around with it, and we do know about CMSs and things like that, so. But we're front-end developers.
Yeah, we're focused on front-end. We'll talk about web components. It's totally applicable to Drupal. We'll touch on a couple Drupal-related things with web components, but you're all Drupal experts compared to us, so we're just here to talk about the web components and that kind of stuff.
Yeah, we're front-end people. Okay, let's get started. Let's get started. So there you go.
Yeah.
You know that we...
And feel like we're in a school here. Feel free to put your hand up, ask questions. Like, don't wait to the end. Like, we're here just to we're here for you. So, so if the little thingy will work.
Yeah, just click on it. Sometimes because I clicked reset, so click on the next slide.
Way to go.
I'm sorry.
Way to go.
Just click on that. Just click on that. Okay. Oh yeah, full disclosure again. Also, we work at Comcast.
Yeah, so we've been at
we're sorry.
Yeah.
Well. Yes, we work at Comcast. We're actually very proud to work at Comcast. Oh, you kick it off. Sorry, I'm stealing your thunder.
You're there. You're happy.
I'm happy. I do work at Comcast.
Yeah, we've been there for over 10 years, which is kind of crazy.
A long time.
Before then, I didn't work anywhere for more than 2 years. I just kind of bounced around. But we are Comcast. We're right down the street. Obviously, they own stuff like MC Universal, so we've got that whole aspect of the company as well. And there, we've built well over 500 web components at this point in the past few years. Chris and myself, we've worked on a number of different websites and projects there during our time there. This is My Xfinity. This is kind of the main customer website. So if you get Comcast at your house and let them kind of set your homepage, they'll set it to this. This is how people get their email, get their news every day. This was built with Ruby on Rails.
And it has a CMS behind the scenes, too, for content.
It does. I helped build that CMS. This is My Account. So this is where you can go in, pay your bill, check on like your devices, that kind of stuff. And this was built with Angular. Can you talk about this, Chris?
And this is the site that I actually originally worked on. This is Xfinity Home, so home security system. This is my house, or a video of my house. So you've got video cameras, lights. I can remote control my lights, arm, disarm my security system, get notified when my door is open. I can control my thermostats in my house. I can turn on all the lights if my wife isn't picking up her text messages. I'm like, hey. But we got 2 kids at home, so that's probably why. And this is written entirely in Google Polymer. Next, we have, of course, the TV platform, so tv.xfinity.com. It looks the same across all the different platforms. The website is also written in Google Polymer using web components. And most recently, we built this single-page app, XFi. So this allows you to control your internet from your smartphone or from the web. If your kids, like my kids, don't come to dinner, I can turn off all their Wi-Fi access, just pause their devices until they come to dinner, and then unpause it once they come. So, very great system.
That's how I find my kids. I just turn off the internet and I hear them scream.
So John, we're here today to talk about components, but all the frameworks like React and Angular, they all have this notion of components. So, what are components?
That's true. So that's true. So if you look at something like React, which handles components really well, it's easily one of the most popular ones. We can see why there's a lot of value in components and componentizing your code. And this here is a quote from React's documentation. So basically, I'll let you read it, but the key point here is that it's talking about building reusable components that are encapsulated so that you can basically reuse the code, and it makes testing and separation of concerns easy. The whole point is that components can be used in isolation and then plugged into a larger system. And this philosophy isn't unique to React. Basically, any sort of framework or library that gives you components is built around this whole idea. But the implementation is going to differ depending on the different framework or library that you want to use. So we'll talk about a component we built at Comcast to kind of demonstrate that. So this, again, is My Account, which I mentioned was built with Angular. So a recent ask we had from our product team was to take that bill pay component right there and be able to put that on other websites, which seems like a reasonable request. We've got that data. Why not show this to customers on any site of ours if they need to get that information? But the site's built with Angular, which means if we want to take that component as it's built right now and drop it in somewhere else, then we need to bring the Angular framework along with it. Otherwise, it's not going to work. So then if we take that Angular component, we want to put it on all of our other websites that are using stuff like React or jQuery or Polymer, then basically we're combining that with all of these different frameworks, which is kind of a waste of overhead and not really worth the effort there. It's all this extra bloat when we just want to get this one little piece of functionality. So then, how can we go ahead and create a component without a framework, Chris? Because that's what we really want.
Well, John, obviously, if you want to create a component without a framework, you need to use the platform. And by the platform, I mean the browser. So Chrome, Firefox, Safari, these are all the browsers, these are all the platforms. And the Polymer motto is to use the platform. And what they've done is they've spent a lot of time creating this web components and the web components spec. And web components are 4 different specs that are new APIs that exist in the browser. So the browser actually has given you new powers that we can take advantage of as web developers. And the first one of these specs is custom elements. And custom elements gives you the ability to create your own tags. I'm going to pause there because I like saying that. Create your own tags. It's so powerful. So rather than writing like divs and p tags, you can now have the ability to write paper tabs. And the definition for a custom element is it needs to have a hyphen in it. So usually at Comcast, we have like XC dash whatever the name of our component is. So we namespace them a little bit. And we're going to see what a paper tab is in this video here. But I just have to figure out where this is. Click play. So these are paper tabs at the top. And to get that markup, all it is this is the markup down here. And we got this functionality at the top, just by including a tag on the page. And that's kind of the power of these custom elements.
Without styles?
We're going to get into that. You're going to love it. Without styles, he's like, wait, I'm used to jQuery. jQuery, I'd have to import this JavaScript, and then I'd have to figure out styling, and then I have to make sure the markup's right, and now you're telling me I don't have to do all that? That's what I'm telling you. That is what I'm telling you.
I like what you're selling.
Okay. All right. I'm going to keep selling this. So in order to get these web components onto the page, there's this spec called HTML imports. And we won't go into too much detail about this because this spec did not fan out. All the other browsers were not on board with doing this. But essentially what happens is you would import an HTML file on your page. Just like you import JavaScript or CSS, you could import an HTML definition. It will automatically dedupe, so if one component contains another component, and there's the same references, it'll make sure, the browser will make sure it downloads it just once. But this is a really great way to include HTML, CSS, and JavaScript all in one file. And so essentially what we mean is that same paper tabs demo, in order to get paper tabs on the page, we import the paper tabs definition, which includes the CSS, the HTML, and the JavaScript, and things just magically work. Switching back and forth. The next web component spec is the template tag. And this, by far, is one of the most powerful ones. Essentially, template tags give you the ability, you got this new tag named template, you can put markup in there, and that markup will do absolutely nothing.
So much power.
So much power. It's like you can put images in there with sources, and the browser will see the template tag. It will parse the markup, but will do nothing with it. It won't actually download the images. And you'd probably be asking, like, why is this useful? And the big reason why this is useful is if you get API calls, you're making API calls, and you're getting JSON back, and you want to quickly create markup. Normally, you would create strings and long strings and create ULs and LIs, and then put in little pieces. And then the browser would have a performance cost of having to recreate those DOMs every time. By using a template tag, you can clone those DOM elements, and the browser will do it very, very quickly. So this is really just for performance optimization.
I'm going to have some questions. This is great, but no DOM parsing goes on in the template. Like, so if you do get element by class name, you're not going to get tab.content bleeding through.
You can.
So initially, like when the browser parses your HTML, it'll like the template of ID, so your ID tab will be there, so you can get a reference to it, but everything inside of it you won't have until you actually clone that.
Yeah, and you can go tab.content and then start doing query selectors of the content in there.
Yeah.
Or actually, I think you might have to clone it first.
Once you clone it, you have access to it.
Yeah, and then it becomes like a normal document fragment is what it's called.
Mm-hmm. Yep.
Are you going to make your slides available?
They already
Yes.
are.
Yeah.
We will let you know the URL after
I'll
in
tweet
the
them
future.
out afterwards.
In the future, at some point, we'll we'll let you know.
Yeah, so you don't have to take too many notes.
So here we'll take a look at how the template tag works. This is hard to switch your mouse all the way over, but there we go. And again, this is a benefit. All of the web components that Polymer creates use the template tag. So that way, if you have paper tab and that repeats multiple times on the page, the browser only has to parse the markup actually once. So it's a really great performance optimization for using the same web component multiple times. And definitely the coolest one is the Shadow DOM. You have to say it like that, really, the Shadow DOM, because he has like the creepy figure of being really dark and mysterious. And Shadow DOM actually provides encapsulation for your web components. This is the ability to create a DOM subtree so that you can put CSS inside of your DOM subtree and not worry about your CSS affecting other CSS on the page. Does that make sense? So I can set my web component to be color blue, and if the page says color green, my web component is going to be blue. And it won't affect anything outside of the web component. That's the power of Shadow DOM. We have yet another video. And what happens in the developer tools, you'll see the element here, and then it has a shadow root. And basically, any CSS styles that you put inside of the shadow root will not affect the rest of the page. But CSS styles still cascade down into the web component. So if you set a global font size or a global color, any properties that normally cascade will still cascade down into your web components.
The ones that don't won't. So if you're just set, for example, like on this one, like if you said div padding equals 10 on the main page, that would not affect this div that's inside of this web component itself, because the shadow DOM is going to block that from parsing down. But an inheritable style like color, like you mentioned, if you said like body color equals red, that will go down into it. But if you set div color equals blue inside the component, it'll be encapsulated with that one and not leak out.
So John, I have a question for you.
Yes.
My mom is still using IE.
She is.
Can we use these things?
It's a great question, and it's an important question to consider about your audience and can actually use it. So back when the idea for web components came about in 2011, and there were some initial prototypes, you definitely could not use them by any means. You would stay far, far away.
I mean, we were using them in production.
Because we're crazy.
Because we are crazy.
But now in 2018, it's definitely safe to go ahead and do it. They finalized the 4 specs, and it was a journey to get there, but we did get there. So basically, the custom elements and Shadow DOM specs went through a revision. So the initial release was a V0. Only Chrome actually implemented it, and then that allowed developers to go ahead and experiment with them and provide feedback to the W3C, and that led to these V1 revisions, which are the current revisions that are being worked on, either implemented or being worked on by all the browsers today. So if you look at the browser support matrix right now, template tag has been around for a while, so that's actually supported across the board. H1 imports we mentioned, that's kind of going away, but is being replaced by ES6 module, so looking at the support for that. So Chrome added that a few versions ago, Safari as well. Edge actually just added that as well, so we're really just waiting for Firefox. And for all of these, basically, with IE11, you can transpile or use a polyfill for them. Custom elements and Shadow DOM, those are supported in Chrome and Safari. They've been there for a while. In Firefox, they're actively working on them. They're behind a flag right now in the developer edition of Firefox, so you can use it in Firefox with that flag set. And then Edge is considering it, and there's a polyfill you can use for these. They actually call it Shady DOM and Shady CSS to handle Shadow DOM, because to 100% polyfill Shadow DOM would be insanely expensive. It'd be a lot of code. It'd be really performance, not good for performance. So they created this Shady thing, which basically allows you to get most of the functionality if you use their API with less code and in a performant manner. Now with Microsoft, you actually go ahead and vote on what features you want them to build into Edge. And the web component specs are actually the most voted on ones. You can see Shadow DOM custom elements are at the top. But it's just like our democracy here. They do what they want to do anyway. So the odd container is actually in development. But the good news is that Shadow DOM actually has this roadmap priority high set to it. So the Edge team should be actually building this out pretty soon. And then usually browsers build Shadow DOM, and then custom elements is a fast follow. So hopefully we'll see this maybe by the end of the year in Edge, which would be awesome to have native support across the board for desktop browsers. And when it comes to basically browsers, you know, how much support are we actually talking about here? So this is the traffic for the past 5 weeks in the US. And if you look at the browsers that support web components, so we add in basically Firefox, which is going to be releasing it into the stable in a few months, it's nearly 85% of browsers are actually supporting custom elements in Shadow DOM. And if we look at mobile, again, I mentioned that it was added to Chrome and Safari a few versions back. So actually, it's practically 100% of mobile devices now. Every mobile device that's sold now supports web components natively. And since performance is so important on a mobile device, because you've got potentially a slower connection and it's a lower powered device, so you're paying more for parsing time, this is huge because as opposed to other frameworks, you need to download the framework, parse it, and interpret it. This is actually providing functionality that's framework-like in the browser itself natively. So you're closer to the metal. It's going to be much faster to actually go ahead and execute web component code. So Chris, yes, we can actually use these things. I'm glad you asked.
That's good to know.
But how could we use them with a framework? I mean, you might want to use them with Polymer, you might not. I don't know.
Yes, you can use them with frameworks, and we actually do that. So at the beginning, I showed you all the different sites that we work on, and we actually have a web component that we share across all of our sites. And that's our global header and our global footer. We call it Polaris internally. This gets about 1 million downloads a day, probably even more than that. And it's such a great resource example for other people to see and look at. We actually open sourced it, so you can go to github.com/Comcast/Polaris, which the slides will be available after this. But you can look at an example of a vanilla custom element that we're using in production. And the great part is that web component actually works across all of our different sites. And as we said in the beginning, we have sites written in Angular, React, just with jQuery, with Polymer. It doesn't matter what the sites are made out of because it's the browser that's doing the work. And it's very simple for our third-party sites or all of our sites to actually use this web component. It's literally include that script tag at the top and then put a tag on your page. And then there's a bunch of attributes that you can set to change the styles of the web component. So you can set which tab you want highlighted, whether the user's logged in, what your sign-in URL is, sign-out URL, and what name to display if you're signed in or not. So,
Does this mean that it's a single point of failure? If that server goes offline,
yes.
there's no caching of it?
No, it's heavily cached. So there's a million requests a day for that, and it's just a static JavaScript file. So it's literally a static file that's hosted by a CDN, and it actually we have 2 redundant origins for it, so it has 100%, well 99.9999% uptime.
So it doesn't work in IE10?
So it does work in IE10, and it will work in Firefox 49 and up.
With the polyfills.
With the polyfills.
Yeah.
So this actually is just using custom elements. And like I said, web components is 4 different specs: custom elements, HTML imports, Shadow DOM, and templates. I'm only using custom elements. The polyfill for that is 2 kilobytes. So it's a really small polyfill, and that's only for the 15% of browsers that don't support custom elements natively out of the box.
Who's maintaining the polyfill?
The polyfill is maintained by webcomponents.org, which is kind of Google and the Google Polymer team. Yeah. And again, this works because your application is written, and that's at the top, and that's written on a framework like Angular or React or whatever, but these web components are being interpreted and run by the browser. So that's why it works across the board regardless of what framework your site or application might be using. And if you're interested in learning more about getting a web component to work with an existing library or framework, Rob Dotson has a website, Custom Elements Everywhere, and he has a video where he talked about getting all these components to work in Angular and React and Vue.js, et cetera, yada, yada, yada. John, do you want to ask me the next question, please?
Sure, Chris. So we're here at Drupaldelphia.
Is that what this is?
Can we use these with Drupal? Is it useful?
Yeah. I mean, this is a great question. So I actually spent the last 2 days setting up a Drupal website, and then I set it up in Drupal 8, and then I had to downgrade to Drupal 7 because I was checking out Hacks the Web. How many people have seen the Hacks thing? And that's all written with web components, which is why web components are probably pretty exciting here. But regardless, I did get a Drupal website up and running, and I put in a hello world tag. And you can do this in authoring anywhere, or you can do it as a content block. It doesn't matter. But you'll see that tag's on there, and by default, you can put any tag you want in there, and the browser will do nothing. until you define what that custom element is.
It basically
So in the-
behaves as if it's a spam tag.
Yeah.
You load it, yeah.
It just behaves as an empty tag. So on the next slide, what I did was in the console, I wrote the class definition to set inner HTML to hello world, and I defined the custom elements. This is all native browser APIs, and as soon as I did that, it changed to hello world. So that tag now exists. So in the same way that you would use content blocks to like copy markup all over the place, you can now create one single script tag that loads across your site, can contain as many different custom element definitions as you want, and then your content authors can just put in the tag name and markup will show up. And that's happening client side rather than server side. Make sense? Cool. So John, obviously the hello world component isn't that powerful.
No.
How would I use some more powerful web components?
Sure thing, so we can talk about that. So basically, when it comes to using web components, there was actually a talk a few years ago at the Polymer Summit, which is just this conference around Polymer, and this guy Ben from ING talked about how really the great way to use web components is to think about the idea that you want to be an assembler first and a craftsperson second. With the idea being basically you want to use existing open source web components first, because there's this whole library out there that's available at your disposal, and then if they don't meet your needs, then go ahead and then go ahead and build your own. So at webcomponents.org is the place to go and search for all these open source components. And then once you go in and you find them, you basically go ahead, you can install it right now with Bower. So you just basically Bower install the element, then it becomes available to you within your local environment. It's going to be switching to Yarn pretty soon. There's Google I/O in a few weeks. I imagine they're going to say that this is definitely the way to do it. They've already have documentation on how to use Yarn, but basically this is just because Bower is deprecated. Yarn is kind of the best way to get a flat dependency tree, which is good for web, to actually download your dependencies, in this case for the front end. And then when you're going to go ahead and actually use it, you're going to import the components. So the original way to do it was HTML imports, which is this. ES6 modules are getting a lot of traction, so this is the way you can do it with that. If you're going to do something like Webpack, you could then use that to handle ES6 modules or rollup. But you can also just load the polyfill for HTML imports as well. We're using the polyfill right now for the most part on our sites at Comcast. And then again, once you load that import, then you have your custom element tags available to you the same way you have a normal HTML tag. If you go to webcomponents.org again, there's collections you can explore there. And then there's, so one of the ones that we commonly use at Comcast is iron elements. These basically provide a lot of nice functionality that you can then use to build your own elements from. Like basically if you want to build a modal, there's a modal here already. There's one for basically taking like a tab interface and some pages underneath of it and switching between each page within that tab interface. Lots of great stuff here. And the end for Drupal stuff, so there's this Learn Web Components set of components available to you. This started out of Penn State, and this is where that Hacks the Web came from. This is getting pretty popular for sure, so I'd definitely recommend checking that out. And we've mentioned Polymer a bunch of times already, so I kind of want to go into what exactly Polymer is. So Polymer is made up of 4 parts. So first there's the main Polymer library, which basically allows you to use web components in a more friendly way than using the native browser APIs, the same way that jQuery made it more friendly to use DOM APIs. Same idea with that. They also, as Chris mentioned, they maintain the web component polyfills, which provide support back to IE10, IE11. Also, they created a bunch of open source web components. So the Polymer team has released probably a couple hundred at this point of components that are available on webcomponents.org. And also the Polymer team is part of the Chrome team at Google, which means that they actually are the ones that can kind of help inform the Chrome developers, which then go ahead and inform the W3C about what is the best way to actually author web components for the future. Like, you know, that's where all this stuff came from, was really a big push from within the Polymer team at Google on how to build these components for the web. Now, when I first started working with Polymer, I myself had a few misconceptions, so I'm going to kind of clear those up first. The first is that Polymer is not material design. When I first saw Polymer, basically every example was about material design. You would see stuff like this, which is all these nice material design things that are built with web components, which is great if you want to use material design. And if you do, then there actually is a whole set of what they call paper elements, which gives you material design. But we don't use material design at Comcast, and you definitely don't need to. So if you want to, that's great, but that's not the requirement for it by any means. Another thing is you don't need Polymer to use web components. That Polaris header and footer that Chris mentioned, it's not using Polymer at all. It's all just browser APIs built into the browser there. But if you want to use Polymer, then you certainly can. It just makes it a little bit easier. It's also not a framework. This is something the Polymer team likes to say. They say that we're a library, not a framework. With their open source components, there's definitely enough to provide you the functionality you're used to from frameworks. But basically the thought and the mindset is that basically you can take this the same way jQuery is a library and it makes things easier to use. It's basically just a library to make things easier to work with web components. And lastly, it's not heavy. It's actually a pretty small library. So if you look at some of the most common frameworks and libraries out there right now, Polymer is the smallest one. So basically this range here is, if you were to take basically the most basic features of Polymer, you can get it in just under 13 kilobytes. You take the full Polymer suite, it's 21.6 kilobytes, and that's still smaller than jQuery, Vue, React, all these popular frameworks that are out there right now.
But
so besides Preact.
Preact is 3 kilobytes. I don't know how they do it.
And again, for something like mobile, this is huge again, because then your mobile devices, they've got all these web components, features built into them already. Now you're just adding a little bit on top of that for Polymer. So this could be a huge part of your mobile device experience to make that more performant. So Chris, Polymer is small, but there is something there. So why would I go ahead and use Polymer?
It's the same reason you'd use jQuery, John. It's a lot easier. And so what the Polymer team says is like primitives are designed so we can build libraries on top of them. A lot of times you don't want to use the underlying APIs because they're kind of hard to work with, or they're a little confusing or a little too complicated. So it's nice to write a little bit of sugar, a little bit of JavaScript to make it easier to work with them. And so here I wrote up the vanilla.js version and the Polymer version. And as far as the JavaScript is concerned, they're roughly identical. So you would still write the same amount of code, except that Polymer, you would extend polymer.element, which is like a base class that gains the Polymer functionality. And then they give you some nicer methods like ready rather than connected callback, which is part of the native spec. Because you know when you have native spec people, they're all about big, long names that are really complicated. And then when you write a library, you're just like ready. Make it nice and simple. The big difference between vanilla.js and Polymer is when it comes to doing the markup and actually writing out your HTML. So with vanilla.js, you would say like this.innerHTML equals a template string, and then you put all your markup inside of a template string. Or I could use a template tag and then copy it and put it in there. But with Polymer, they actually use another web component, DOM module, and then a template tag, and they actually take responsibility of stamping your template in. So they kind of abstract some of the things and make it a lot easier for you to work with it. So I would recommend that if you are only going to write one component, or you have a component that is going to be downloaded a million times, used across all different websites, you should do it with just vanilla.js. If you are going to write lots of components, you should definitely use a library or framework of some sort. And you don't have to use Polymer. There are lots of other ones out there right now. Skate.js is pretty popular, and Stencil is actually written by the Ionic team who do native apps or web apps stuff. So definitely check those out. If you are a purist and like vanilla web components, check out the Elix project. They actually have a bunch of classes that you can use to jumpstart your web components that you can extend.
And that's at elix.org.
Yeah, elix.org is the website. And they also publish the gold standard for web components. One of the nice things about using web components and taking advantage of code that already exists is they follow this checklist of making sure it's accessible, that it works well across browsers, that it handles all the different edge cases, that your screen reader can go from left to right and right to left, and etc. So it's always good to copy code. That's kind of like why web components are great, because you're basically copying code. So, John, how do I build a Polymer component?
That's a great question. So let's go ahead and talk about how we can actually go ahead and do that. So there is a CLI tool that Polymer offers, just like any good library or framework. So if you install the Polymer CLI with Node, that will provide you a bunch of different features. Once you install it, you can run Polymer help. You can see actually what's available to it. So there's an analyzer that allows you to basically analyze your code. There's a build process to prepare it for production deployments. Help shows you this stuff. You can initialize a project, so you can install dependencies with just Polymer install. There's a linter as well that's very useful, because for one reason, like you asked, like if, for example, if you forgot to load in the definition of custom element, it would it would be the same as if it didn't load at all. So the linter will catch those for you. Serve gives you a nice little server that'll just spin up locally in a second. You can also run tests from Polymer as well. So when it comes to actually writing a component itself, you would use, it'll be the Polymer init command right there to initialize the Polymer project. That will allow you to initialize either an individual element you want to create or an application. And then there's that starter kit that actually gives you an idea about, builds like a full app for you out of the box and then customize to your needs. But if you're going to build an element, you would then choose a Polymer 2 element. That's the most recent version of the library right now. There's a Polymer 3 in development. It'll probably be announced to Google I/O in a few weeks as being stable. But it's pretty similar to Polymer 2, and right now you would use Polymer 2 as your element choice. Once you select that, it asks you a number of questions to help build the element for you. So here we'll just name it Polymer 2 element, give it a brief description for the bower.json, and then it's going to create a number of files there, and then go ahead and install your dependencies. As Chris mentioned earlier, you always have to make sure that your element name has a dash in it. That's the way that the browser knows that it should be loading in, or at least looking for an element definition to load in for it. And then this is what your directory structure is going to look like after that loads. So you've got your Bower components to hold your dependencies, if you have any. You'll have at least web components, polyfill there, and Polymer. Typically there will be a demo folder to create a demo page, a test folder to run your tests in, and I'll have a base test for you there to work from. Your bower.json is going to handle your dependencies. It gives you a base index HTML file to look at the documentation for it. In this example, my element HTML is the actual element itself that you're loading in. Polymer.json is a configuration file for when you want to run linters and the build process and that kind of stuff. And then it gives you a README, so it's kind of ready to go for open sourcing your component. So once you generate that, if you were to actually run Polymer serve and load up the demo page, so it gives you a demo page out of the box, which is pretty sweet. When the Polymer team goes ahead and they build their components, and as well as us at Comcast and most open source components, you go ahead and you build demo pages for how to actually use it. This is an example of the demo page for paper tabs. And then you also get some really great documentation as well. And the way the documentation works is basically you've got Markdown you can write within a HTML comment, and it will parse that Markdown and then generate this documentation for you on the fly, which is huge, again, for open sourcing it or even just using it kind of inner source within your own company. It can also then, a common thing to do is when you're styling it, it uses CSS custom properties. So you want to define what custom properties are going to be exposed so people can customize the styles of it. And again, this is just markup that's going to generate that, or Markdown, sorry. And then if you use JS doc syntax to document all of your properties in Polymer and any methods you have on your element, it'll go ahead and actually generate documentation for that as well. So it does all this automatic documentation, so it's easier for people to use and understand your components out of the box, which is really helps for adoption of it. When you go ahead and do that, again, I mentioned so you're going to document the JS doc syntax. That index page will then use this iron component page component. It actually uses a component to generate that documentation, so it's very meta in that sense. And then the CLI will actually go ahead and then create this analysis.json file that will then allow you to then load in all that information about the component with the documentation itself. So again, these slides will be, I'll tweet them out there so you can download them. This is the real basics on how to actually go ahead and get free documentation. I also mentioned, so it has a test suite built into it. So it has a tool called Web Component Tester. This allows you to write tests using Mocha, Chai, and Xenon, and then actually run these tests in the browser, which is great because then you can actually load it up in a browser and test it out there. For a continuous integration environment, you can use something like, we use Headless Chrome to run these tests, or something, or you can use Firefox headlessly. It's also possible to use something like Karma, but WCT works right out of the box when you create a component. Another nice thing that Web Component Tester gives you is this accessibility suite. So if you want to test your components for accessibility, there's a set of, I believe, 11 tests that you can programmatically test. And basically all you need to do is, this is how you typically create a test within Polymer. You have a test fixture element, which Polymer gives you. You give it an ID, and then you can reference that ID in your tests. And then if you want to actually run some accessibility tests against that, all you do is call the accessibility suite function and pass it that ID of your test fixture, and it's going to run this set of accessibility tests right there. So it's nice to have this kind of small accessibility audit right out of the box. Demo time. This is Chris's favorite part.
This is my favorite part. I've been waiting for demo time the whole time. Because it's one thing to like talk about this stuff, but then it's another thing to actually like show it in progress. So I think I'm going to mirror screens.
Yeah.
So just bear with us as I change displays to mirror here. And so,
Do we need to make it a little bit bigger?
yeah, I'm definitely going to make it bigger. Boom. So what I have here is I've already done the Polymer init. I have the Polymer CLI downloaded. I actually ran npm install Polymer CLI globally. I did Polymer init. And right now in my terminal, I'm running Polymer serve, which is the command from the Polymer CLI after I already did my init. And what that generates is this. Yes. So this is the default app that Polymer creates when you use their generator. Oh, wait, it looks like that. So I kind of cheated. There was like a little thing in there. So now what I'm going to do is I'm going to add a paper fab. Does anybody know what a fab button is? Yes, audience participation. Okay, so a fab button. A fab button is a floating action button. It's this little cute thing here. And I like cats. Does anybody like cats? Anybody cat? Dogs? Sure. Babies? We really have to change this around to be babies. So inside of the index page, essentially your entire app is a component, my app. And so now we are opening the my app component definition, and this is the my app component definition. And so now I want to add a paper fab button. So I'm going to go into the template here. I'm going to add paper fab, and just by copying an example here. And at first, when I hit reload, it's going to do nothing. It's going to show up nothing, and that's because I didn't import the definition for paper fab. And I've already taken the liberty of doing Bower install for these components to download it locally, just because you never want to trust Wi-Fi at conferences. It's like a thing. I don't know why. So now I just need to import paper fab on my page. So boom, save it, hit reload. And now I got a button that showed up in the top left.
A floating action button.
A floating action button. And I do want to emphasize right now that all this code is running in the browser. That Polymer serve, all it is an HTTP server serving static files. There's no pre-processing, no magic happening behind the scenes, nothing changing any of the source code that you are seeing here. This is all real stuff.
And Chrome supports innately, so you're not even loading the polyfill in this case.
And then your paper fab button is just like another HTML element on the page. You can style it just like you normally would. So I want to position absolute this thing, and I want to say put it in the bottom, 25 pixels, and I want it right, 25 pixels. And the cool part is like this little button down here, it has a ripple effect, so when I click on it, it actually does a ripple, and I didn't put any CSS markup on there, did I? Did anybody see any CSS? No. But we also talked about the shadow DOM. I really don't like pink. I don't know. It's like a gender thing. I don't like pink. I want to make it blue.
My son likes pink. What's your problem?
Your son likes pink?
He's a
My
boy.
son likes yellow. His like favorite color is yellow. That's actually, I don't want to make it yellow though. So with web components, there's actually this other thing called CSS properties that you can actually change styles, and web component authors can expose different properties that allow you to change it. So here I'm going to change paper fab background color. Just going in here, and I want to say paper fab background color. I'm going to go blue. I like blue. Blue is my favorite color. So now I did that, I changed it, and now it's blue. But obviously, like this button being here doesn't really do much for us. How many people like dialog boxes? I love dialog boxes. They are a pain in the butt to implement. So let's make it easier. There's actually a component called paper dialog, and I always like grabbing sample code, because never ever write markup yourself if there's a sample code that you can copy from somewhere. And I'm just going to put this down in here. I'm going to give it an ID tag so I can use it. I don't really need this scrollable area. And I'm going to call this cat pictures. And you'll notice that the linter is saying, hey, I don't know what paper button is. And I'm going to add a method on here. So the Polymer framework gives me an on tap. And I want this to call open dialog, like that. And I'm going to have to write this function open dialog down here in the my app. So I'm just going to write a function. And this is using JavaScript classes down here. So open dialog. Typing is the hardest thing that you do all day.
Yeah, it is.
And with JavaScript classes, you actually don't write the function keyword. It's really weird, but you'll get used to it at some point. And now I can say this .dialog.open. Well,
This $$ basically says find the element with an ID of the next property, which is dialog.
And also paper dialog is green too. So I have to go up here and I have to import paper dialog, and then I have to import paper button. This desk is not at a good height for me. So now I have this button, and when I click on it, if I coded everything right, this dialog box shows up in the middle of the page. No CSS, no special markup or anything. It's like this dialog box is there. But I really want this to be a modal. I don't want it to be whatever that was. And the cool part about web components, again, is if we go to the web component documentation, I called an open method on here, which open. So it has documentation about all the methods that are available on this dialog. Open is one of them. That's what actually got it to come up. There's another one that I know of because I worked with this before, is this modal attribute. So if I just go in here and I go back to my paper dialog and I add an attribute of modal and I click save, reload this, and now open this, it actually grayed out the rest of the background. And it's fully accessible. When I hit tab, it's just keeping it in those buttons. It's not actually tabbing outside of the modal. But
and you hit escape and you got out of it.
I did hit escape and I got out of it. Like that's magic.
That
This
just
is like, it's magic stuff just happening. But I did promise cat images. So boom. This is my notes because I don't want to write this load a cat image. There's actually an API called the cat API, which will give you a random cat image. Image ID equals cat image. Boom. So now every time the dialog opens, I want to say, give me a random cat image. Woo! Yay! But it's off-center. So there's a quick way to solve that. And that's because I'm loading in new content inside of a dialog that doesn't know. So there's a method on here called notify resize, which I put in my notes. So I'm going to say when the cat image loads, on the onload of the image, call the dialog notify resize, which is the method on notify resize. And I'm just going to bind the this to be the dialog so that it has context of the dialog. And so now I can hit the cat button all day, get a centered image of a random cat. I can close this, open up a new cat image. This one's pretty good. I think that's cute. Yeah, usually they're much better than the ones that we've been getting. Let's see if this one's good. There we go. That's getting good. It's a little bit bigger than the box, but we're not going to fix that. So I hope you can see like the power of web components. I just threw that together in a couple minutes, and you have all these paper elements that are exposed that give you material design that you can just throw on a page, and stuff just magically ties together and works. And no processing, nothing happening behind the scenes. So let's get back to our presentation, John. Where is that presentation?
Somewhere in the Chrome.
Somewhere in the Chrome? Oh man. This is really the hardest part, is why... I'm going to let you continue this wherever that presentation is. Okay, little elevator music. So I think the demo's over, and then we go back to present mode, and then I ask you a question.
Is that how it works?
That's how this works. This is the trade-off. When you do co-presenting, you ask each other questions. It's a good way to trade.
Chrome.
Chrome.
Trying to be helpful.
Why are you not helpful?
There
we go. There we go. Whew. So,
all right. We did the demo. We did demo
Yeah,
time.
I didn't get any applause though. I don't know if it was that cool or anything. Thank you. It's very hard to do live demos. Your hands start shaking and you're at awkward height. So John,
it's a question, Chris.
John, I have to ask you this question so we can continue. What are some best practices if we want to use web components?
I'm so glad you asked. All right, when it comes to components, the really thing that you want to focus on is, for these to be useful, you want to be able to share them. Maybe you want to open source them, but maybe the big thing is like within your team and your coworkers, how can you share them? Because if it's easy to share them, then people want to go ahead and actually use them, and they'll trust it. Yeah, we have to get our kids in there somewhere. This guy. This guy. So how do you make shareable components? The thing that we found most effective is actually have a team that is focused on it so that they can be the ones that are caretakers of those components. They can help kind of solicit, what people need, what's the best way to use them. And then one thing to kind of help provide a confidence in them is to, again, use that web component tester tool and then have a high amount of test coverage on it. So we actually will have our builds fail if test coverage isn't high enough. This is kind of insanely high. But basically, this helps to kind of provide a high level of confidence, like I mentioned. You might be wondering, do we use TDD when we rate our components? Maybe. We don't really enforce it. But one thing that I do kind of run around the office yelling about is DDD, and you're probably wondering, what is
John? What is
this
DDD
thing? So DDD stands for demo-driven development. So I mentioned those demo pages that Polymer has, and this is really just incredibly useful. So here is our Xfinity Home ARM disarm component. And this is what our demo page looks like. So when we're building our components, we always are looking at the demo page first. And our demo pages will show a actual working component as well as the markup required to render the component in that format. So here is kind of the slimmer version of it, and in this case we used a class name to make it look like that. So this is class equals short. So the great thing about demo pages is that you can then basically, for consumers of a component, they can go into a demo page and see what is the markup required for it and how will it actually look with the actual component itself. And then when you're actually going ahead and building components, as you're making updates to it, you just need to look at the demo page and then you can see all the possible ways it can be used across your various websites. So when we update this component here, if it's used on 4 websites, you don't have to check all 4 websites because our demo page has the use case for each of the 4 websites. So it really helps to speed up development time because you're not testing on all those different websites. You can just trust that the demo page looks good, this is how it's being used, you're good to go. Another thing that we often do is, at least in our case, we use CORS a lot, which is cross-origin resource sharing. So when we're fetching data to actually use for these components to use, it's typically going to be calling an API that is not the same as the page it's on. So if you use CORS, that's going to help you actually make that a possibility in the browser. This page here from Mozilla gives a great rundown. Actually use that if you're not. And then, again, along the same lines, a real important key here is to separate your data from the UI. And what I mean by this is basically your UI components should just basically take in the data it needs as attributes and properties and then render it. It shouldn't be taking in a large set of data and then processing it. That should be happening outside the component. The component should be more like a dumb component, kind of like the whole functional programming paradigm where basically it's more pure, you just pass in some data and expect the same output every time. Same idea when you're building components. And I know that Chris really loves to talk about data flow a lot. So you want to talk a little about data flow?
I will talk about data flow, and we're sorry, this is not really Drupal related, but we work a lot in Redux. Has anybody used Redux here? No? Anybody know what Redux is?
There we go.
Okay, it's like a front-end state store. So, I mean, you can think of it as your CMS is your state store, but we usually do our state store in JavaScript on the front end, meaning we make calls to APIs, we get data back, and then we create like a state store in the browser so that we can render front ends. And what I mean by this is, so this is our UI, and we keep it very simple so that when you click on buttons, the web page doesn't know what to do, right? This thing just fires off an event, and like a kid, they say, what's that? What's happening? What should I do? And you don't really want them to do anything. You want them to come to you and say, hey, let's fire this event back up to the app, give it back to our state store, our JavaScript layer, and then it's your responsibility as the parent to figure out what should be the new state. So this is like going all the way back to the CMS or going back to your PHP layer to do some business logic and then send a result back down. So I would do new calculations, pass the new state back to the front end view, and then the front end would update and change the button from pause to unpause and change the device states. If you're interested in Redux and Polymer and web components, there's a great video on it by Rob Dotson that you can check out. But I think this is really important because it allows decoupling of responsibilities. So separating your view from your business logic is one of the great things. Computer science really talks about this a lot, and they have a lot of big words for it, like encapsulation, composition, separation of concerns, functional decomposition, and it's all about breaking your stuff down to do one thing and keep it really simple. And why you'd want to do that is because simplicity matters. If you haven't checked out Rich Hickey's talk on Simplicity Matters, I love this talk. I watched it over and over again. I actually have a talk called Decoupling with Google Polymer, which I reference this like a dozen times throughout because it's really good for programmers.
It's applicable to all aspects of programming.
All aspects of programming. If you write code, you should watch this video. And really, you want to write simple things and keep your code base simple because simplicity creates opportunity. It allows you to develop faster, make cleaner code, and add new features. And so we have a lot of useful links that will be sent out in the slide decks. You can follow us on Twitter. Hopefully everyone enjoyed the talk and is still awake with us. This is my daughter. Yeah, she is adorable. I love that little baby. But thank you all for your time, and I hope you enjoyed it. If you have any questions, we're available to answer questions. We have 9 minutes until lunch.
Good point.
Does creating these components like your header and footer put you at greater risk for like phishing?
That's a good question. So, and to answer your question, like we're pulling in scripts from different domains, right?
Yeah.
And so that puts us at risk of phishing attacks because there could be other JavaScript loading. And so we use CSP headers, content security policy. So you can actually tell your server to return CSP headers, which will tell the browser only allow JavaScript execution from certain domains.
Okay.
So we have that set up so that we're only loading content from Xfinity.com domains, and that's all we trust.
Okay, cool. So like if you had a session logged in on your site, somebody fished that header, you go there, you're not going to be logged in. Chances are they may not even see it.
Correct.
Okay.
Correct. Yeah, and a lot of like our API communication, we use implicit OAuth, so we would get an access token, and any communication that we do with APIs is sent over SSL.
Okay.
So there's no worry about people cracking it. Other good questions? Any other questions? We take any questions of any kind.
I have another question.
You have the floor.
When you were styling the color of the background of that button, it was something that the component provided.
Yes.
Are you allowed to override that if the component doesn't provide an override?
Take it. You love
so
CSS
no, so that's kind of the point of the Shadow DOM. Basically, you as the author of the component get to decide what you want to expose. So in that case, for that one, there was a background property for that.
Yeah.
Now there is something that Polymer has called CSS mixins.
Yeah.
So if you're familiar with Sass, it is not Sass mixins. It basically is instead a way to give a way for a user to dump in any sort of styles that they want for that element. So you can basically say that was probably like a div tag that made that circle there. So you can say, okay, for that div, there could be a CSS mixin exposed that is, for example, like paper fab mixin. And then you as the author can then enter in any sort of CSS you want, as the user can enter in any CSS because that was exposed. That's only if the author exposes that mixin for you. And commonly they are in the places that make sense for it. So basically this happened because the Polymer team, they had all these open source components, and they would get like an issue opened up every day, just like, hey, let's style this thing. Hey, let's style this part. I want to style this part. And they just kept adding properties. They're like, this is silly.
So if you find a component that doesn't expose something you could override, you can just copy that component into your local and
you can
make
change
your
it.
own. Yeah.
Okay.
Yeah, exactly. It's more for like one inside of that, and that's where the Shadow DOM encapsulation comes into play. So it's nice because then those styles can't be messed by something from the outside, which is great. And also they don't leak out and affect things inside of it too.
And CSS properties are another native browser API, and they're just kind of like Sass variables. You can define them globally, and they work across anything, and they have nothing to do with web components, right? Like you can use them regardless of web components.
Yeah. Anything else?
You can also talk to us during lunch too.
Yeah.
We
And again,
we eat food as well.
I'll send out a tweet with the link to the slides. So.
You can just upload them on the site.
Oh, cool. I'll do that as well. Perfect.
Cool. All right. Thank you all for coming.